Okay, so last class we discussed we started discussing about plotting, and last class we mainly discussed the example about pandas itself plotting. Okay. So what today we will go over, we also covered the concept about the Matplotlibs plotting. Okay. Yeah, for some reason today's and so we cover the concept. So what today we will do is we will go over the examples. Okay. So in order to use Matplotlib, you need to import the Matplotlib submodule pyplot. Okay, normally we import as PLT. And for this is a first example. And we are going to use NumPy to create two NumPy array. And so we create one NumPy array and assign it to X, and create another one and assign it to Y. Okay. And if you recall last class when we discussed the concept about Matplotlib and the pandas plotting, the difference between these two is for Matplotlib, you need to explicitly specify X and Y. So the X coordinates and Y coordinates, kind of like that. Okay, so you need to specifically provide the X and Y values. And for pandas plotting, it doesn't have this requirement. So from the data frame, okay, it can automatically, so if you specify certain column, it can automatically based on that and to do the plotting, okay. And so over here, we do the plotting with the X and Y coordinates. And also in Matplotlib, last class, we also discussed one of the major benefit for it is it has rich settings, okay, and also configurations for the drawing canvas, okay. Later on we will see. So now in this case, you also wanted the X and the Y coordinates to have labels, is it? So you provide the label and also give the plot a title. And also if you wanted to the graph be shown, you needed to also provide this show method. Okay. And then in this case, then it will generate a graph. So basically this is a line graph. Okay, so it will generate this graph for us. So this is a very simple example, and I haven't touched about the drawing figure. Okay, what the next one did is, if you recall, last class we also said this figure function, basically it create a figure object. Okay, so over here it's going to create an empty, we also can call it like a canvas. And on the canvas, then you can add subplots. So over here we add, so the first two argument, it tells us the subplot is going to be a 2 by 2 grid. Okay, so you have two row and two column. Okay, and the third one is specify the number one, number two, number three. Okay, so which one? And so you can call this add a subplot method. So this subplot then will be created on the canvas that this figure returned. And you can also, you see, for this add a subplot, it return a subplot, and you use a variable to remember it. Is it okay? So after you add a subplot, then for each specific subplot, is it? Then you can do the plotting and specify. Okay, so here the plot is to do the line plot. So that's the first one, doing line plot with the previous x, y values. And the second one is to do the scatter plot. So you call the scatter method. So it will use the exact dots. Okay. If you recall last class, we also discussed line plot. Generally, it reflect the trend for continuous data, and the scattered can also reflect the correlation. Okay, and also like the trend, okay, and the clustering. But over here, it's mostly like the trend. And the third one is a histogram. And the last class, we also discussed the histogram. So histogram is about frequency distribution, okay? So here, the value is going to be divided into, so we provide 20 bins, okay? And then it will provide the distribution, okay, among the 20 bins. So over here, because the histogram is going to return some value, so you just use an underscore. So underscore in Python, basically it's a placeholder, okay? And we are not going to use it anymore. So you don't need to assign a variable to keep it, so that in this case, we can save memory, okay? So in this simple example, it shows you can create a window, create a canvas. Then on canvas, you can add each individual subplots. Okay. And the next, let's take a look. So for the next one, what we did is over here, we create, you can also call the subplots. So the pie plot, the subplot method. So this subplot will also create subplots. Okay, so in this case here, it creates the drawing canvas and subplots using object-oriented approach. Last class, we also mentioned. So over here, it's one row with two subplots as like two column, okay? And here, this figure size is for the complete canvas, okay? So each subplot kind of take like, because it's horizontal, it's 8x4, okay? And here, for this one, last class, we already discussed this stock data. So it's from 4 ticker, is it 3 months, their daily closing price and the daily volume, okay? And last class, we also discussed the XS, so cross section, okay? And the cross section is more beneficial to multi-index hierarchical data frame, okay? So here we are going to pick the closing price and the volume column, okay, from the level 1, okay, the inner one, okay. So you get the two data, and what over here it does is for the closing price, okay, the index is a date, is like the year, then -01, -01, okay. So it's a date, and it's going to convert it to NumPy, okay, so that later on it's more compatible. And we can then for each of the column, we can also find like the maximum, the highest price and the lowest price and the respective date. Okay, so here the ID is the date. So you can find the highest and the lowest. So that's pandas. And then we can start to do the plotting. So here, if we go back to take a look, so if you take a look, this subplot function, is it? So this subplot function, if you recall, it return two items. The first item is the canvas, is a figure object. The second one is subplots. Okay, so it return two items for this axis. So these are the two subplots. So the two subplots basically are stored in a sequence. Okay, so that's why over here you get sub-0 is the first subplot. And then later on we will see the sub-1 is the second subplot. Okay, and then we start to do the plot. And here we have four ticker, is it? So you get their ticker, and this is the dates. And that's why over here you convert it to NumPy because this is Matplotlib and it needs the X and Y values. Okay. So that's why you don't use the datetime index. Okay. So this is X value and the plot this is the price, so price, this is the Y value, and you call the value part, okay? And then you also specify the color because it's the plot give you line graph. So you can also specify how the line width. And for each sample, you can also specify some marker, okay? And you also provide the label for it. So for each of that, you can also define like the line style, etc. So we choose different line style, okay? So that's regarding the plot. And then over here, so what this section does is to configure the subplots on the canvas, okay? So you can specifically call like set title and specify a title. You can also call the set X and Y label, okay? And the legend. And here the legend, you just let it pick the best place. You didn't specify, okay? And the next part is to do some annotation. We can first take a look, okay, what it looks like for that closing price. Then we come back to explain the some details. So we already saw like, so this is the Tesla one, okay, it's just a draw line, and each dot is a marker you specify. If you take a close look, you will find the other three line, we didn't specify marker, but we specify using different the line style, is it? Yeah, and also over here you gave the label, and over here it's the yeah. Do you have a question? Hello?
Yes, ma'am. I have a question regarding the assignment. So, you gave an assignment for chapter 3 and 4. In that, you have mentioned that you have to do exercise on page number 71 and 98.
Mm.
So, whatever the question are present on that specific page, that question only we have to do, or the entire exercise?
Yes, I remember that's the case. Yeah.
Uh,
Can I first finish the discussion about the material at the end of the class? I can go to Canvas and let's discuss about the assignment. Will that be all right?
Yeah, oh, that's all right. Okay,
Okay,
you can
thank
continue.
you.
Yeah.
Mhm. Okay, so we discussed the different line style. Oh, and over here, then it's the X ticker, kind of like the Y ticker, and here is uh, the title. Okay, and if you take another look over here, we have this highest price and lowest price, is it? And we also have the arrow point to it and plus text. So these two are annotation. Okay, so later on we will explain how do we add annotation on the graph. And this part is a legend. And because the legend we set is as best, so it will pick what the program think the best place so that it won't overlap the original graph. Okay, so next let's see how do we deal with this annotation. The annotation, yeah, over here. So the annotation, the first one is to find the highest, okay, annotation. So what over here, it is the text, okay? So you provide the text and you can also format it. So F means you format the string, okay? And within the curly brackets, if you recall previously at the beginning of the semester, we also discussed, okay? So this maximum price is a variable, so it's a placeholder, okay? And you format it with 2 decimal point. And then over here, you specify the X and Y. So the coordinate, okay, on the graph, because you want to know, okay, the coordinate of the X, Y, okay? So that's what this X, Y means, whatever point you want to annotate. So this we already find the highest price date and the highest price. Okay, so you can put both in a tuple and assign it to this X, Y argument. And what this part is that annotations text where on that subplot you want it to be put, is it? So the x-axis is the same, okay, but if you take a look at the y-axis, it's different. So it's based on the price and plus. So because it want to not exact the points, a little bit of higher, is it? So this point is that highest price. If you see that highest price is it, so it start at exactly the same x. So the x value is exactly the same, but the y value is add another 220, is it? So it start, if you take a look over here, it's 20. So it adds another 20, so it's a higher, okay. And then this is that formatted text. So this part is for the text part, okay? And also over here, we also saw the arrow, is it? So you can also provide the arrow, and here it's a dictionary. You need to provide the color for the arrow. And here it also said, okay, you want to have a little bit of space because you don't want it to go directly on the dot. You want to have some space. So that's it's going to shrink a little bit. Okay, so just 5%. So it's hard to see here. Okay. And the next is about the output, the font size. So the font size you provided and the font color and if it's bold or not. Okay. So all of this is regarding the annotation. Okay, that's regarding the highest price. For the lowest price, it's similar. So it's pretty similar. Okay, so that's regarding the first subplot. And for the second subplot, so similar, but this time it's regarding the volume, okay? And so it's pretty similar as the first one. But this time, if you take a look, the drawing will happen on the second subplot. Okay, so here we have two plots on one canvas. And if you just use pandas plot, you cannot achieve this effect. Okay, so if you want to do something like this, then you need to pick Matplotlib. Okay. And what next? Let's take a look. See, this time for the settings of this second subplot, we didn't specifically call the set. You see, call the set title, set label, set legend, yeah, those functions, is it? And we provide all of the settings in a dictionary this time. Okay, so the title, the label, and the ticker, and the ticker label. This is for a Y. Okay, and if you take a look, the Y ticker, yeah, it also provide it's a quite a large number, is it? Some millions at least. Okay, 30 millions. And so this time we group all of the settings to a dictionary. And then you just call this one set function and pass in this dictionary to this set function. So all of the settings then will be plugged into this set function. So all of the settings, then it will be configured on this sub graph. Okay. And also be careful because you pass in a dictionary, so we have two asterisk ahead of it. If you recall, in chapter 1, we discussed the one asterisk and the two asterisk, okay, in different scenarios. And also for both of these two subplots, we also, if you take a closer, you will find the grade is also on. As you can also set grade be true, okay. And also over here is so here it calls also another function called also this auto formatting kind of, okay, for the X. This is for X axis and mostly for date, okay. It's just to try to avoid because your X axis, the tickers, this is X tickers, no, it's quite long, is it? And if you don't do that, they may overlap with each other. But if you call this, then it can format it nicely for us. Okay. So this example is showing, yeah, we can do configuration on the subplots. Okay. And the next one is for Matplotlib for the ticker is that we can do some formatting thing. Okay, so let's take a look. Then you need to import the respective class. So over here, we are going to have the closing price, mean, and the volumes summation. If you recall, because we only have four ticker, four stock, is it? So basically for this mean, we are only going to have four values. And for the summation, we also going to have four, is it? So this time similar, we call the subplot function, and it returns a canvas and the subplots, okay? And the subplots is on the same row, but with two subplots, so two column, and also specify the figure size. Okay, and what this part done? this is a closing price, okay, that data frame, and you want to find like how many items in it, and then you call the range to generate some sequence, okay, so that you can assign it to this variable. And similar for the volume, okay, you assign it to the variable. And this time for the two graph, for the first graph and for the second, both we are going to do the bar plotting. And if you recall, the bar plotting, what it does is it shows a comparison among different among different category of objects. Okay, so from different categories, it will show the difference. And over here, you provide the bar because it's also on the XY coordinates. So you provide the X value and the Y value. So the Y value is the price, okay? And because here we have 4 different stock, and so that's why you want them to be shown in different colors. So you can specify the color. So similar for the volume, okay? And this time we just do the old way, just call the set function for title label, okay? And then over here, we define a function, formatter function. So what this function does, so this is the formatted output, okay? And it's going to be format this variable, okay? And some variable then times this value. And if we take a look at the volume, they are or like 1e plus 10. Okay, so 1e plus 10 times 1e minus 10. So it's kind of they canceled out. Okay, so then they won't have that e. Okay, so just without that like larger number, just some decimal number. Okay, and then it will be convenient for us to remove that this 1e10, okay, on the y-axis. So that's the purpose. So to remove that, then so only deal with y-axis. So you specify this is for y-axis. Then you call this set major formatter, and then you plug in whatever this function we just defined. Then it will cancel out this 1e10. Okay, so it will just show. So the result, if you take a look, it looks like this. Because on label, we already gave the units. So over here, it's just to show the decimal point without those 1e, because otherwise those 1e10 is going to show somewhere here. That's kind of disturbing, is it? And we want our graph look more clean. So in order to do that, that's why we define this format function to remove that. Okay. And after that, we also set the ticker. Okay. So the ticker is, so X ticker is X axis, and the Y ticker is for the Y values. So we also set the labels. Okay, the label is going to use the index. And so here we have the output from the bar, okay, graph. And previously we mentioned bar graph is mainly for comparison. Yeah, so you can see from this bar graph, it's very obvious. Is it like for the transaction volumes on NVIDIA during those 3 months, it's highly traded. It's a much more than the others, okay? And for the price, you can also see like Apple, okay, in those, the mean price is the highest, okay? So this is regarding the bar plotting. And the next example, if you recall, last class, we also discussed with the newest version to generate of the stock data. Okay. And so for those stock data, yeah, so the data looks like this. The data, okay. Data looks like this. Data looks like, so we have so this is two level. Okay, you have the outer level as ticker and the inner level as the price. Okay, and the daily price. So that's the data. Okay, and then what over here we try to show in this example is, in this example we integrate both the plot method from the data frame pandas. So we use pandas plot method, but at the same time, we also use Matplotlib to do the configuration for the plotting areas configuration, the setting configuration. Okay, so then how do we do that? Is it so over here you call the subplots to generate the canvas and the subplots. So here we have 3 rows and 2 columns. So we are going to have total 6 subplots created. So they are going to be arranged in 3 rows and 2 columns. And here is the canvas size. Okay. Then next, let's see, how are we going to handle that? Is it how do we, because the plot method in this it's from the data frame. So where do we associate the subplots with the plot function? So basically, pandas plot method, it provide us an argument. It's AX, and with this, you can specify the subplot. So this is 0, 0, the first row, first column. This is the first row, second column subplot. Then the second row, first columns subplot. This is second row, second. So where each subplot supposed to locate. Okay. So you can, using this AX argument, and then we integrate the Matplotlib's subplot with pandas plot. And the remaining title kind, you see, similar as what we already learned last class. And also this time, we also specify like the X and Y values here. Okay, you can also do that. It's pretty straightforward, is that you specify, okay, because over here, we do scattered, so we wanted to find the relationship between like a pair of the tickers closing price. Okay, so you specify the X and Y values. Okay, and because of that, you can also do configuration and settings. Okay, we just do the grade. Okay, set the grade as true, and also you can adjust the layout. Okay, because here you have multiple subplots, so to prevent the title and label overlapping. Okay, and then show. Then here is the result. If you take a look, yeah. So for each row, you have two subplots. Each row you have 2 subplots. So total we have 6. Okay. So this is regarding integration of pandas plotting method and Matplotlib together. Okay, so then in this case, you can take advantage of both. Okay, and the last example we are going to cover is regarding something looks like this. Okay. And this we call it a hexabeam. Okay. If you recall, last class we discussed histogram. Histogram is about frequency distribution, is it? So hexabeam has some similarity like histogram. It can also do the frequency distribution. Okay. So what over here is instead of the bar, okay, so it uses some small hexagon, okay, for the frequency. So this diagram, it's compare it finds the price of Tesla and NVIDIA, okay? And over here we have this bar, and this we call it a color bar. So color bar has a number. So the darker the color, the higher the number the is, okay? And this normally shows the frequency. So frequency in this case is the number of occurrences. So it's count. Okay, it's count. And so if there are more occurrence like in these two places, is it? Then the color of the hexagon, the color is going to be darker. Okay. And so when we use this hexabeam is if your data size, you have a lot of data, okay? And if you recall previously, we also mentioned scattered plotting. Scatter can show this kind of correlation, is it? And the clustering and the trend, show off those, is it? But if you have a lot of data, and also assuming if a lot of data also kind of clustered together, if you just use a scatter, then that will look like too crowded, okay? And it's not easy to give us the very obvious visual result. So then in this case, then you can choose this hexabeam. Yeah, because with the hexabeam, then it just use the darker color to show, okay, over this area, you have more data points. Okay, like in those areas, you have fewer data points. So it's also very obvious and clear, is it? So that's the case that we use this hexabeam for the frequency distribution, okay? And so hexabeam, then you can use Matplotlib, okay? And so similar, we do the figure configuration. Then you call the hexabeam, and you provide the X and Y values. You also can provide the grid size and the color map. This is a color map. You can choose other color, okay? And you can also give your color bar some label, okay? And similar X, Y label and the title. So after you provide the configuration for the settings and with the data, then we will have this graph be generated, okay? So that's all of the information regarding Matplotlib. And from our discussion, we can see Matplotlib is richer, okay, because it can do configuration, okay, not like a pandas plot method. But pandas plot method, the benefit part for it is it can directly extract data from the data frame and then do plotting. Not like Matplotlib, you need to specify X and Y coordinates kind of, okay, X, Y values. And we can also integrate both together, okay? So we discussed two approach for, generally speaking, for visualization. And the next one is regarding CBOM, and we are going to cover it in our next class. Okay. So today, the new material, we are just going to cover the Matplotlib. So we are going to stop here.